guys, this looks like a fun one. It is not a fun one. We're given a matrix multiplication containing x, y, z in dubs. And it wants us to solve for x, y, z in dubs. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. I'll show you how to do this matrix multiplication. Since this value is in the first row, the first column, we're going to do this first row by this first column. It'll be x times x, which is x squared, plus y times 1, and that's going to equal the 7. And then for this x to the fourth minus 5, it's in the first row, second column, so we're going to do first row, second column. X times 1 is x, plus y times y is y squared. And that's going to be equal to x to the fourth minus 5. And then for the 9, it's the second row, first column. So we're going to do second row, first column. Z times x plus w times 1. And that's going to equal 9. And then for the 4 dubs, that's second row, second column. So we're going to do second row, second column. Z times 1 plus w times y equals 4 dubs. So we have 4 variables and 4 equations. And to make things a lot easier, the top 2 equations contain just 2 variables. So we can focus on the top 2 equations first. For this one, let's get the y all by itself. Let's subtract x squared from both sides. And we end up with y is equal to 7 minus x squared. So in the place of this y, let's plug in 7 minus x squared. And then here's the next step. This x will be brought down. The quantity 7 minus x squared multiplies out to give us 49 minus 14x squared plus x to the fourth. And then on the right hand side, we can copy down the x to the fourth minus 5. Both sides of the equation contain an x to the fourth, so let's subtract x to the fourth from both sides. And after all this cancels out, that leaves us with a quadratic, so let's set it all equal to 0 by adding 5 to both sides. 49 plus 5 is 54, and this negative 5 plus 5 will change into 0. And now let's rearrange this in descending order. I prefer leading coefficients to be positive, so let's divide everything by -1. This will become positive 14x squared minus x minus 54 equals 0. And now let's do the quadratic formula. It'll be x equals -1, which is positive 1, plus or minus square root of -1 squared, minus 4 times 14 times -54. Whole thing over 2 times 14. And this will simplify into 1 plus or minus square root of the quantity -1 squared is 1, and subtracting 4 times 14 times -54 is the same thing as adding 3024. And the whole thing will be divided by 2 times 14, which is 28. On the inside of the square root, 1 plus 3024 is 3025. And 3025 is a perfect square. The square root of 3025 is 55. And now we have x is equal to 1 plus or minus 55 over 28. Since it's a plus minus, that means we have 2 values of x. We have this positive version and the negative version. For this value of x, 1 plus 55 is 56, and 56 divided by 28 is 2. So x equals 2 is one possible solution. And then for this one, 1 minus 55 is -54. And -54 over 28 can simplify to -27 over 14. We have 2 possible values for x, which means we might have 2 different scenarios. Let's use this equation to find the corresponding value of y for each scenario. For this first one, in the place of x, let's plug in 2. 2 squared is 4, and 7 minus 4 is 3. So when x equals 2, y would equal 3. These are some nice looking numbers. Now let's go to these less nice looking numbers. In the place of this x, let's plug in -27/14. When we square this, the negative is going to end up going away, because negative times negative is positive. And then the 27 and the 14 are each going to get their own squares. 27 squared is 729, and 14 squared is 196. And now to simplify this further, we need a common denominator. 7 is the same thing as 1372 over 196. And this minus this gives us 643 over 196. And now we have the corresponding value of y for this value of x. I suspect that this scenario is going to work out nicely. I'm nervous about this scenario. Let's keep going. Now that we have x and y, I don't think we need this equation anymore. Let's split up the 2 scenarios and give them each their own box. And let's copy down these 2 equations for each scenario. In this first scenario, in the place of this x, let's plug in 2. And in the place of the y, let's plug in 3. And let's rewrite this as 2z and 3 dubs. Okay, this is nice. There's 3 dubs here and 4 dubs here. Let's subtract 3 dubs from both sides. On the left-hand side, these two will cancel each other out. And on the right-hand side, 4 dubs minus 3 dubs is dubs. So we have dubs is equal to z. So for this equation, in the place of this dubs, let's plug in z. 2z plus 1z is 3z, and then we can divide both sides by 3. On the left-hand side, we'll be left with z, and on the right-hand side, 9 divided by 3 is 3. And now in the place of this z, we can plug in 3. So we're now done with scenario 1. We've solved for x, y, z, and dubs. Now let's focus on scenario 2. Let's swap the zx, and in the place of the x, let's plug in negative 27/14. And same thing for the dubs y. Let's swap the y and dubs and scoot this over. In the place of the y, let's plug in 643 over 196. Now this is nowhere near as clean as this one was. For the next step, I don't really like fractions. Let's get rid of these denominators. For this top equation, let's multiply both sides by 14. On the left-hand side, this 14 is going to distribute to both of these terms. When we do to the first term, this 14 is going to cancel out. So we're left with negative 27z. And then we can distribute it to the second one. We end up with 14 dubs. And then on the right-hand side, 9 times 14 is 126. And now let's get rid of the 196 on bottom here. Let's multiply both sides by 196. For the second term, the 196 is going to cancel out, leaving us with 643 dubs. And then for the first term, this will be 196z. And then on the right-hand side, 4 dubs times 196 is 784 dubs. Next, we can subtract 643 dubs from both sides of the equation. These two will cancel each other out, and 784 dubs minus 643 dubs is 141 dubs. So now we have 196z equals 141 dubs. Let's get the z all by itself. Let's divide both sides by 196. That ends up giving us z is equal to 141 over 196 dubs. Now we're going to end up plugging this in for this z. Let's give ourselves a little more room. In the place of this z, we're going to plug in this. This negative 27 will multiply by the 141 to give us 3,807. And then now to combine these two dubs, we need to give it a common denominator. 14 is the same thing as 2,744 over 196. And this plus this is going to give us negative 1,063 over 196 dubs. Now from here, let's get the dubs by itself. We're going to multiply both sides by the reciprocal of this. On the left-hand side, since this was a reciprocal, all of this is going to cancel out. And then on the right-hand side, this times this gives us negative 24,696 over 1,063. For scenario 2, this is our value for dubs. And now to get z, in the place of this dubs, we're going to plug in this fraction. This times this is this, and this can simplify to this. And now we have z. These are the solutions for scenario 1. These are the solutions for scenario 2. Let's verify that they work. In the place of these x's, we'll plug in 2. In the place of the y's, we'll plug in 3. In the place of the z, we'll plug in 3. And in the place of each of these dubs's, we'll plug in 3. Now let's do the matrix multiplication on this left-hand side. For the first slot, we're going to do first row times first column. So it'll be 2 times 2, which is 4, plus 3 times 1, which is 3. And then for the next slot, we're going to do first row second column. 2 times 1 is 2, plus 3 times 3 is 9. And then this is second row first column. It'll be 3 times 2, which is 6, plus 3 times 1, which is 3. And then the last one is the second row, second column. It'll be 3 times 1, which is 3, plus 3 times 3, which is 9. And then 4 plus 3 is 7, 2 plus 9 is 11, 6 plus 3 is 9, and 3 plus 9 is 12. So good news, the 7 and the 9s match, but let's check the rest of them. Let's smush this all together and bring down the right-hand side. The 7s match. 2 to the 4th is equal to 16, and 16 minus 5 is 11. So these two 11s also match. The 9s match, and down here 4 times 3 is 12. Let's smush it all together, and this matrix equals this matrix, so it checks out. This is a valid solution to this equation. Let's put a box around it. And now let's check scenario 2. In the place of each of the x's, we'll plug in negative 27 over 14. And in the place of each y, we'll plug in this fraction. In the place of the z, we're going to plug in this fraction. And in the place of the dubs's, we'll plug in this fraction. Now let's do matrix multiplication to the left side of this equation. This times this is this. and this times this is this. And then for this one, this times this is this, and this times this is this. And then for down here, this times this is this, and this times this is this. And then for this one, this times this is this, and this times this is this. And luckily this simplifies to this. These already have a common denominator, so we can just add them together to get this. And this simplifies to 7. So we're off to a good start. These match. Now for these two, they don't have a common denominator. So we're gonna have to multiply top and bottom of this fraction by 2,744. And after we multiply these, we get this. And then this plus this gives us this. And this won't simplify any further. Now for this one down here, to give them a common denominator, we need to multiply top and bottom of this one by 14. After we multiply this times this, we get this. And this minus this is this. And that simplifies to 9. So once again, we match. And these two fractions already have a common denominator, so we can just combine them. This minus this is this, and it doesn't simplify. Now we can check out the right-hand side. Negative 27 over 14 to the power of 4 equals this. And then this fraction minus 5 gives us this. And these two do match. And then for this one down here, 4 times this gives us this. And these two also match. So it checks out. So these values of x, y, dubs, and z also gives us a solution to this equation. Let's put a box around it. Here are the two solutions to this equation. How exciting.